we are going to use to distinguish between an aldehyde and a ketone. And I am starting with some more addition reaction of carbonyl compound, like nucleophilic addition of carbonyl compound. Let us take once again acetaldehyde, ethanol, IUPAC nomenclature. In the IUPAC nomenclature, we write down the name for acetaldehyde as ethanol. When I react this one with hydrogen cyanide, in this case what is happening? Hydrogen cyanide is going to split up as H positive and Cn minus. Cn minus, any negatively charged species are nucleophiles. Now here when the nucleophile has to get attached, now in this compound somewhere I have to create a positive charge. How the positive charge is going to create it? Oxygen is drawing the electron in this part. So here oxygen is going to develop a negative charge and carbon atom is going to develop a positive charge. So the cyanide part is going to attack the carbon and the hydrogen part is going to attack the oxygen. And here I am getting the compound as C, this part as H, and similarly to the carbon atom, if I join it, cyanide, and here to the oxygen, the hydrogen goes, I am writing it like this. In general, whenever I have got a compound having OH and cyanide, such type of compounds are called as cyanohydrin. One of this reaction, you will be also studying in the lesson biomolecules, reaction of glucose with HCN, where you are going to get the compound as glucose cyanohydrin, which is going to confirm that glucose structure has got carbonyl group. This reaction is a base catalyzed reaction. In presence of a base, the cyanide is easily released, the nucleophile. Let me go to the next one. The same way, if I react the same compound with sodium hydrogen sulfite. This is sodium hydrogen sulfite, also called as sodium bisulfite. If I take the same compound, it is not necessary that I have to take the same compound. If I react with this, once again apply the same concept. Here this oxygen is going to develop a negative charge, the carbon is going to develop a positive charge. Always remember, to the oxygen, the hydrogen is going to get attached. The remaining entire part is going to get attached to the carbon atom, and hence the structure turns out to be like this. To the oxygen, always OH, like how I have done to the oxygen hydrogen. This hydrogen goes to this oxygen, OH part, and the remaining part SO3Na. The name of the compound. This name is nothing, this is an addition product. An addition product in short is called as adduct. If you see the word carefully, the adduct, there are two parts in that. From addition the word add has come, product UCT part has come. I will add now one more reaction. Once again a nucleophilic addition in the carbonyl compound. Now here apart from the nucleophilic addition, there is a bit of elimination also. Now here if I take an aldehyde, I am taking ethanol once again. To this I am adding an alcohol. I am writing like this, ROH in general. This is an alcohol I am adding. Now this reaction in the presence of dry HCl gas. I will also tell you the reason why I am taking dry HCl gas, that is what is the function of dry HCl gas. Apply the same concept what I have done it for hydrogen cyanide as well as for sodium bisulfite. Make it once again here, it is oxygen is going to become it is going to develop the negative charge, carbon the positive charge. To the oxygen always the hydrogen gets attached and OR is going to get attached with the carbon atom. In that case here I am going to get the compound. Everyone will be able to write down this just like the previous two reaction. Now this compound, I am putting this in a square box as this compound is unstable. This compound is called as hemiacetal. Hemiacetal. If I just write down R, if I just like write in place of R as CH3, methane is becoming CH3, alkane is becoming an alkyl, so it is methyl, alkyl. Now if to then alkyl, if I just join an oxygen, oxy, alkoxy word, methoxy, So in this compound, I've got a hydroxyl group, I've also got an alkoxyl group. Let the reaction further continue, allow the reaction to react with another molecule of alcohol. When I react this unstable hemiacetal with another molecule of alcohol, an elimination is going to take place here. How the elimination is going to take place here? This ROH and this OH, I'm going to remove an H2O molecule. If I remove an H2O molecule from this, I'm going to develop a stable compound. This stable compound is called as acetal. Now here the structure is going to turn out to be CH. There is no change in all these three things. So in place of OH, this is OR, here this is hydrogen. Now this part, this is OH and this is ROH. Just remove the water molecule, what we are left out with OR. I'm not going to put a square bracket here because this is stable compound. It was unstable, I just put a square bracket so that you remember it. This is hemiacetal, this is acetal. Just see the difference between the two structure. Here I have got an OH group, in place of that OH group I have got an OR part. Can I call this compound as a dialkoxy? I can say that acetal I have developed a dialkoxy compound. In the previous reaction, the reaction of an carbonyl compound with an alcohol, I turned out to be, I made the product as hemiacetal which was unstable, and then I have written as acetal which was stable. I put dry HCl gas. I told you that time that I am going to tell you the reason. The reason I am telling, the role of dry HCl gas is to direct the reaction in the forward, and also it is helping in the second step, that is elimination of water. This part you should remember. This can be asked in the form of a reasoning type of question. Now let me take another reaction. This I am writing in the form of a question. This can be asked in the form of a question. Please note it down. The question can be, give the preparations of primary, secondary and tertiary alcohol with the help of Grignard's reagent. This let me tell you in the form of a question itself. I am writing in short. I hope everyone remembers what is the Grignard's reagent. It is RMgX. Now everyone can note it down. When a carbonyl compound reacts with Grignard's reagent, it gives an intermediate. The intermediate undergoes hydrolysis to give rise to an alcohol. Now let me take an example. Once again I am going to repeat the statement if you would not have understood. I have taken a compound. I hope you will be able to make out the compound what I have written. Always try to make out what is the IUPAC name as well as the common name. I hope everyone remembers the common names are also called as trivial name. This one is methanol. The trivial name is formaldehyde. Formaldehyde is a gas, and if I pass this gas through water, I am going to get formalin. The formalin is used to preserve the biological specimens. This is now methanol. I am reacting methanol with Grignard's reagent. RMgX, alkyl magnesium halide. If I react this, again the same way what I have told you, this oxygen is going to develop a negative charge, carbon a positive charge, whatever part is R. This R can be alkyl as well as aryl. This R part is going to get attached to the carbonyl carbon. The remaining part, the magnesium and the halide, is going to get attached to the oxygen. And so the intermediate what I am going to get is HCH to the carbon atom. The R part is going to get attached and the remaining part is getting attached to the oxygen. So I am writing it like this, OMgX. This is an intermediate. Now this part undergoes hydrolysis in presence of zinc dust. Now what is happening is, now this part is undergoing cleavage and thus H here and OH here. And now the product comes out to me. I am just drawing the structure as it is, H, C, H, on the top here R, Oxygen is left here, oxygen. To the oxygen, this H. And the byproduct, Mg, I am putting Mg and the OH part inside bracket, and X. The name of this compound is magnesium hydroxy and whatever is the halide. Now, if you find difficult to write like this, you can make this compound this way, R CH2 OH. Now, here you see this is a primary alcohol, 1 degree alcohol. Now, I hope you have understood. Suppose here R I am taking CH3, then this R would have been CH3, this R would have been CH3, this R would have been CH3, and ultimately what I have drawn is ethanol. Ethanol is a primary alcohol. I hope everyone has understood this part. I am going to the second part. Now, I am taking this part as ethanol. I am taking this part as ethanol, as I have written formaldehyde. I am always writing this so that it is clear to you. Always remember, in an organic reaction, the name of the organic reactant as well as the organic product must be mentioned. It can be either the IUPAC name or it can be the common name, but you must write. It is not necessary that both as I have written you have to write. I am just writing so that you can remember it, at least one of the name you remember it. Ethanol is nothing but acetaldehyde, as we studied in the last class. The concept remains the same. I just, in place of H, I just put CH3. So, I am just changing only that place. CH3 here, CH3 here, and here it is one more CH3, only that much. Just by making this hydrogen as CH3, I have got now this a 2 degree alcohol. Now, let me make the third one, this part I am taking, and the third one I am making this one to be a ketone, and thus the name goes as the IUPAC name. It is a ketonic group. So, the name here 3 carbon atom. So, the name here is propanone. What is the common name for propanone? Are you able to remember? Used as a nail polish remover, used to clean the audio cassettes. This is acetone, and let us apply the same concept. Now, what I have done, it was H, that H part only I have replaced with CH3. So, this H CH3, this H CH3, I am making this part as CH3, and thus now what I have turned out to be, this one is now a 3 degree alcohol. Ultimately, the concept remains the same. That means, carbonyl compound when react, I am making the statement once and what I started initially, the carbonyl compound whether it is an aldehyde or a ketone, when it reacts within Grignard's reagent, when it reacts within Grignard's reagent, I can have either an alkyl group, a branched alkyl group, I can even have a ring here. It is going to give rise to an intermediate. This undergoes hydrolysis in presence of zinc dust, and you get an alcohol, either a primary or a secondary or a tertiary. When I start with formaldehyde, I am going to get a primary alcohol. Starting with acetaldehyde or other, I am going to get a secondary, and then similarly when I start with a ketone, ketone will always give rise to an 3 degree alcohol. I want everyone to there is 2 questions. The in-text question, what is given in the second lesson, alcohols. Okay, now if suppose if there is any question on Grignard's reagent, till now I am giving you different reactant with Grignard's reagent, intermediate, and you are getting the product. Now, suppose the product is given to you, and how do you find out the reactant? Means what is the carbonyl compound as well as what is the Grignard's reagent? How do you do that? Now, let me just take the same example what I have quoted just now. The first one I have just now taught was ethanol. The next one I taught you as the propan-2-ol. And the last one, the 3 degree alcohol, I taught you was 2-methyl propan-2-ol. This was the product. My question is, how do you identify the carbonyl group and the Grignard's reagent? Do one thing, in the rough, you split up the structure, especially the carbon atom to which OH is attached, even split up that part. So, this is CH3, CH2H, split up this part. Now, just see here, I am telling this one is the carbonyl compound. I am writing CC means it is the carbonyl compound. It's just a tip to remember. And this part, whatever is left out, now this part is the Grignard's reagent. GR I am writing, this is nothing but the Grignard's reagent. Now, in this case, this is O. So, here this one is my carbonyl group. I can have even this part, CH3CH, I can even have this part as the carbonyl group. Now, here I have taken this one as the carbonyl group. Now, this part is going to my Grignard's reagent. When I say this part is Grignard's reagent, means methyl, magnesium, any of the halide except the fluorine. Now, in this case, I can have like this, the carbonyl group. This is the Grignard's reagent, the carbonyl group. Now, the question comes, in this case there is no problem. Now, here suppose I would have taken C2H5. Suppose this is the compound. In this case, I can either I take this one as the carbonyl compound, that is acetaldehyde. Now, the Grignard's reagent is going to be ethyl magnesium halide, or I can have even this one as the carbonyl group, C2H5 CHO. In this case, this is propanol. Then the Grignard's reagent is CH3, means CH3 Mg, any of the halide. Then how do we find out? For that, one of the part has to be given, even for this one as well as for this one. For example, I am giving a question here. One of the question was there in the board in the flow chart. I am writing here as identify A. Identify A. I am writing it like this, A. This is the first part of the question, A plus, I am writing it like this, CH3 MgBr is going to give me CH3, CHOH, CH2, CH3, and the question once again, identify A.